If you use that kind of language with data and say, I'm going to twist it, break it, melt it, sit on it, play with it, tear it apart, you find yourself in murky territory. Is data still data, or has it now become something else?
Hello and welcome to Working Scientist, a Nature Careers podcast. I'm Julie Gould. This episode in the Art and Science series is dedicated to data, how scientists can be creative in data analysis and presentation, but also how artists use data to communicate challenging scientific ideas and their associated emotions. In keeping with our art and science theme, each episode in this podcast series concludes with a follow-up sponsored slot from the International Science Council. The ISC's Centre for Science Futures is exploring the creative process and societal impact of science fiction by talking to some of the genre's leading authors. What could possibly be artistic about data? Data by itself can be impenetrable. Lists of numbers or reams of text don't really give us any information. But it does form the backbone of the scientific method, thinking and discovery. Without it, we just have opinions, ideas, theories about what is happening. The data gives us evidence about the world around us. And many people believe that this is objective information, fact, truth.
If we think about data, what is data really? I think we can think about data broadly as just a representation of some facet of the world that we've captured in a format that a computer can work with, right? So then data analysis, data in general gives us an entry point for making art or music or creative work that connects to the world in some way.
This is Rebecca Febrink, a professor at the Creative Computing Institute at the University of the Arts, London. Rebecca is a classically trained musician with a computer science PhD, and so she comes to her work with an interdisciplinary background. To her and many others, data can be a really interesting backbone for art as well as science. But to do this, the data needs to be curated, cleaned up, and analysed so that we can see what stories it is trying to tell us. And these acts of data curation, cleaning, and analysis are artistic and creative in themselves.
Any kind of data analysis itself is creative, right? Data analysis is all about asking questions, and it's about asking the questions that you didn't even know you had necessarily when you started. That's a very creative process, and it's very similar, I think, to the questions that an analog artist might ask if they, start with a wood that they want to sculpt somehow, or a digital artist might start with if they say, all right, I've got a blank computer screen. What pixels should I put there? What code should I write there? These we call them wicked design problems of really trying to iteratively explore and make sense of something where it's only at the end of this process that really the questions you are trying to answer.
So how can art and creativity help us find these questions so that we can see the answers? Duncan Ross, the Chief Data Officer for Times Higher Education, a higher education publication that uses data visualization extensively in university rankings reports, says that data visualization can be helpful because it brings into play different parts of what it means to be a human being.
We all know that the way we react to things visually is very different than the way we react to things intellectually. So that ability to see patterns and interpret things using images can give powerful insights you can't get, or you can't easily get, by simply looking at numbers.
But it's important to use the right visualization for the type of data that you're communicating, and also the story you're trying to tell. You want to have that interactive ability for people to answer any question they might like to have, but you don't know what those questions are going to be up front, which makes it difficult to build a visualization which will work well for everyone.
You want to have an interactive ability for people to answer any question they might like to have. And you don't know what those questions are necessarily going to be up front, which makes it quite difficult to build a visualization which is going to work well for everyone. So as a result, you tend to stick to a number of relatively straightforward and well understood visualizations, because that's another challenge you have. You don't necessarily know how familiar the people who are using the tool are going to be with a particular type of visualization. So we do use some radar charts. We use box and whisker plots a lot, which are a way of viewing a distribution. We do use line charts. We do use bar charts as well. But the key thing is they have to be appropriate for the data we're trying to visualize and also the information we're trying to get across.
Duncan finds that sometimes using simple visualization is best for helping people understand complex data.
So much of the way we display university rankings is very boring. We put a table up because at the end of the day, although a table you may think, well, that's not really visualization, it is a mechanism that many of us are familiar with. For everyone who follows sports teams, every day we go and look and desperately try and understand why our favorite team isn't as high up the table as we believe they should be. So the table itself is something we shouldn't necessarily underrate. But where the visualization from our perspective really starts to get interesting is when we dig in below those headline numbers. So as well as producing the tables for the World University Rankings and the impact rankings for external use, we also share with universities some of that underlying data so that they can start to understand how they compare with their peers, hopefully in order that they can, do work that will improve not their position in the rankings, that's not so important, but they can actually understand how to improve as institutions and perform more strongly on the world stage. And there we absolutely want to use visualizations. We need to be able to show universities where they sit compared to similar universities. We need to help them to understand the shape, and that's a very visual word to use, but the shape of their institution compared to other institutions. So that's really where we start to use that visualization more deeply.
James Bayliss, a data visualization expert at Springer Nature, is working on their new tool, the Nature Navigator, which creates visualizations on a digital platform to allow customers to experience data at different levels. Now, some of his work is simple, charts and graphs and the like, but some is more in-depth, letting customers adjust certain parameters to understand the story from their own perspectives. But for whatever visualizations he's trying to build, James always starts with a blank canvas.
My go-to tool is a pad and paper or colour pencils. I think it starts slow and don't get too complicated too fast, hence a sketch pad. Because you have to start very low res, low fidelity first, then medium and high fidelity, polished designs, then you go to coding. You don't want to start off with coding. I've been in projects that have started off with coding and got all tangled up in masses of code.
Akshat Rathi, a senior climate reporter at Bloomberg News, uses data to illustrate his journalistic stories. He says that sometimes the most simple visualizations have the most impact in his stories. And in 2015, whilst he was working for the business publication Quartz, Akshat wrote an article with a colleague on the devastating earthquake in Nepal.
The thing that struck people in the newsroom at the time when I was describing what an earthquake means when it's at a magnitude of 7.8 was surprising to some, because when they learned that the numbers of how earthquakes are described is based on a logarithmic scale, not a linear scale, people couldn't quite get their head around what it means if an earthquake is 6 on the magnitude versus 8 on the magnitude.
Akshat and his colleagues started by assigning a magnitude 2 earthquake to one small pixel.
A square that you can see, but it's really small. And then you look at 4, and you look at 6, and you look at 8. And every time that box becomes much, much bigger than a simple 2 to 4 to 6 to 8 would linearly. And then you compare it to a 9. And the visual essentially becomes a scrolly box. You keep scrolling, because it is just so much bigger than an earthquake that was only 1 magnitude smaller. And to me, that was a powerful way of showing what logarithmic scales can do and what devastation a single increase in magnitude of an earthquake can bring.
Because we've explored a little bit about how to choose what visual to use to describe or depict the data, I asked Akshat how he and his colleague decided on the simple box visual. He said it was partly because they were time-bound, because the news article needed to be out in a timely fashion, and partly because they were limited with what the website could do, but also because it served a purpose.
Because we knew that if you convert a logarithmic into an absolute, you suddenly start to see numbers with many, many zeros. We thought rather than showing the number of zeros, which is one way of showing that increase in the magnitude, wouldn't it be better if we showed it in an actual physical box? Because when an earthquake happens, the thing that most people see is an actual physical devastation. You see buildings fallen, you see people in rubble, and those images stay with you because they are distressing images and you see people suffering. And we wanted to try and replicate that level of impact that would come from actual visuals rather than simply putting them in numbers.
Sometimes the visual or oral representations of data aren't meant to obviously explain what the story is. Their role, as many artists and scientists have told me for this series, is to invite people into the work to think, to ask questions, and to feel connected to the data. Nathalie Miebach, an artist who uses basket weaving as a medium to represent the data she collects, did this exact thing when she started working with art and science.
My beginning point where data and sculpture kind of intersected was astrophysics. And when you're studying astronomy or astrophysics, you're dealing with very abstract numbers, distances that are just long distances, numbers that are incomprehensible. And for me, making sculptures out of the things I was learning in astronomy was a way of making that science more tactile, more understandable. As a tactile learner, I had to sort of figure out how to somehow make this understandable.
Her main interest and inspiration is weather data. There's an abundance of it, and it's something that impacts everyone. And it's also part of her bigger goal to understand climate change and its impact on people. Now, she feels that data collected by someone else and presented to you as spreadsheets or numbers and graphs has already had a clean-up and all the anomalies have been removed. And she felt like in order to really understand what was going on, she needed to do this herself, to learn the process of data collecting, but also to fully understand what the data was representing.
So, since 2006, when she was doing a residency in Provincetown, a small coastal town in Massachusetts, Nathalie has been collecting weather data using homemade data collecting tools.
A compass, it was a thermometer from the kitchen aisle from the local hardware store. It was a rain gauge from the garden aisle. I would build up my own data collecting devices that I could use to measure wave height and cloud cover. So it's very, very basic stuff. Now take that stuff out to the beach every day for 18 months, and I would just collect things. I would collect numbers in the sense of I would take the temperature readings of the water, I would take the temperature readings of the air, I would look at the wind direction, pressure, but I would also spend a good deal of time just writing down what I was seeing. So what kind of stuff was washing up on shore, what kind of plant material, what kind of birds were out in the waters, were they migratory birds, were they birds that stay here all seasons?
So all these observations that Nathalie made form the basis of her sculpture using basketry. Basketry offers an interesting parallel to the traditional scientific forms of visualization. Baskets are made with horizontal strands called weavers, which are like an x-axis on a graph, and vertical strands called spokes, which are like the y-axis.
So if you have 48 spokes, you have a 24-hour clock basically, and then you just basically start weaving. For example, when does the moon rise? Okay, it starts rising at 8 p.m. So I start weaving and then I stop weaving when it sets, let's say at, 4 a.m. And then I do the same thing with the sun. And so it's sort of sculpture by number. So basket weaving became this really easy way of taking basic calendars or basic data sets and translating them into a kind of time frame that was dimensional.
Her sculptures don't show any resemblance to the traditional XY graphs that most of us are familiar with, and to be honest, sometimes they don't look much like a traditional basket either. Which begs the question, is it art? Is it data? Is it both? Or is it neither?
It's a contradiction. I love it. So every day I walk into my studio and I walk into this contradiction, because on one hand, as a sculptor who's working with basket weaving techniques, I know that in order to really understand the medium and the technique, I have to fail with it 100, 1,000 times. I have to sit with it. I have to break it apart, melt it, twist it, contort it. I have to basically just fail in so many ways for me to really understand what is the potential of this technique, what is the potential of the medium that I'm using or the material that I'm using. If you use that kind of language with data and say, I'm going to twist it, break it, melt it, sit on it, play with it, tear it apart, you find yourself in murky territory. Is data still data, or has it now become something else?
This conflicting emotion is what drives Natalie to continue her work. She acknowledges that there is this side of science and data where there is this shroud of truth, an untouchability of data. It's something that cannot be changed or translated because it's data.
But any kind of visualization of data, any kind of translation of data is a form of distortion of it. So you'll never, ever get the pure data. Working with data is a bit like creating maps out of something. And a map is never a map is always a distortion of something. It can never contain everything. And so is a data visualization. It can never, ever contain everything that you're looking at, the complexity of the system. So I'm kind of curious about how much pressure and how much expectation we place on data, and also how much we associate the truthfulness of data with the visual languages that we see them in.
Take, for example, a piece Natalie made that was based on a tidal chart. It's a 6-foot woven basket sculpture that translates 1 year's worth of moon and sun data from Boston, Massachusetts. It's got info on it about when the tides were happening, how high they were, the moon phases, and the sun azimuth.
It's basically, in a sense, a 3D calendar that I'm weaving, one year's worth of sun and moon data. And it's a very twisted, distorted form. And it's the numbers that are twisting and distorting the form. And the reason I say it's the numbers that are doing that, it's because I'm using a material that I cannot fully control. If I exert too much pressure on the material, it breaks. It's a natural material called reed. And so it's really these two data sets, the sun and the moon over time, that are distorting the grid of the data. So the form itself is made of the data.
This piece was exhibited in very different locations, and each one got a very different response.
This piece was in a science museum. So people read it as a title chart. And then after that, it went to a craft museum. And it started this whole conversation about what is the utilitarian purpose of basket weaving, and what is its history, and how can this sculpture, this object now have, what is its function really? Because it's not really functioning as a traditional basket in the way that it would fit into the history of basketry. And then, of course, you put it into an art museum and it becomes this aesthetic object.
What this demonstrated to Natalie is that translating data into artistic mediums brings up all sorts of biases and expectations when we think of data and enter it into different spaces. But it also makes her wonder how much we trust the data. So her question is,
so why would it be that the title chart that I used as the beginning for my piece is more trustworthy or more scientific than my sculpture? Both are, in a sense, translations. Both are, in a sense, confined by limits of their own medium. So a graph has limits just as much as a sculpture does. So I'm interested in that tension. I also really don't know what happens to data when you translate it into an artistic medium. I'm not sure if it is still data. Maybe it's become something else, but I love that it's making me ask that question. And it's been a source of discomfort ever since I started, and I love it.
What I'm trying to say with this series of episodes is that the scientific method is creative, it is artistic, and that the subjects of art and science, or art and data, are deeply intertwined. Science requires creative thinking from the point of asking questions, through data collection and data analysis, and all the way to presentation. It is a way for us to have a greater awareness and understanding of the complex world around us. So in the next episode of this series, I'm speaking with 3 people about what the future of art and science will be. Will artists and scientists be pigeonholed into their respective disciplines? Or will we start seeing more and more interdisciplinary careers and departments at university institutions that allow people to follow their passions in both directions? But before you go, the music for this episode was kindly provided by Matthew Jackford. The piece, Shifting Winds, was inspired by a musical score that Nathalie Miebach created from one of her datasets she collected as part of her work. And also, don't go just yet, as we've got the sponsored slot with the International Science Council about the creative process and societal impact of science fiction.
Hi, I'm Paul Srivastava from the Pennsylvania State University, and in this podcast series, I'm speaking to some of today's leading science fiction writers. I want to hear their views on the future of science and how it must transform to meet the challenges we face in the years ahead.
AI in the future, maybe it could be used to help us to reflect ourselves as a mirror to make us become a better human being.
Today I'm talking to Shufan Stanley Chen, an award-winning Chinese writer. I read his novel The Waste Tide many years ago and was impressed by his portrayal of the predicaments of electronic waste. His most recent co-authored book, AI 2041, 10 Visions of Our Future, wittily combines imaginative stories with scientific forecasts. We spoke a lot about artificial intelligence and how we can harness the power of this incredible technology while avoiding some of the dangers it poses. Thank you very much for joining us, Stan. Welcome. It's amazing the range of scientific topics that you have mastery over is really notable. How did you come to be interested in these scientific topics?
So as a sci-fi fan, I have to admit that I started from all of those Star Wars, Star Trek, Jurassic Park, classic sci-fi movies and books, animations back in the day. Each time it gave me a lot of new inspiration and ideas. So I was always totally fascinated by all this science imagination of the future and outer space and even like species millions of years ago. So how we brought them back to life.
So science has been going on for a very long time, What is your general view on science as a human endeavor?
To me, it's definitely a huge achievement, and of course, it makes us living a better condition as a human being. And when we look back to history, I have to admit that there's a lot of challenges because it feels to me like the agency is not absolutely in the hands of human beings. Sometimes I feel that maybe science and technology, just like some kind of species, like some kind of biological beings, it has its own purpose, it has its own birth life cycle. It wants to be and evolve together with human beings. So we are like the host, they are like the virus. We can see it in that way or the other way around. So I always feel that there's very deeply entanglement between science and human beings. So sometimes I feel that we've been changed a lot by all this development of science and technology, but we never know what is the direction ahead of us.
Well, let's make it more concrete and focus on what is top of mind right now, which is artificial intelligence. How can we ensure that in the development of AI, we bring in social justice and ethical and moral considerations into bear?
The problem is we didn't fully invest to build up this kind of regulation and framework of like ethically prevent something negative from happening. I think we need more diversity on AI and especially on large language model because when we're talking about specifically alignment, right? So even among human beings in different countries, cultures, language, we didn't have this kind of shared alignment as a single standard. So how can we teach the machine, the AI, to be aligned with human value system or the standards as one integral one? So I think this is something very preliminary, but I think the key input should be not only from the tech companies, from the engineers, from all these people doing the thing in the industry, but also from the interdisciplinary world, such as anthropologies and psychologies, sociologies, for example. We need more diverse perspective from humanities, because AI is supposed to be built for the people, to serve the people. But the human factor right now, I can feel that is quite missing in the loop.
At some point in the future, do you think that AI will understand more than what humans can understand?
So what I've been thinking about is some model, like large model beyond human. For example, the data from animal, plants, fungi, even from micro, and the whole environment. So we're talking about the whole Earth model. We need to deploy this kind of sensor layers around the world. So maybe we can using smart dust, which was mentioned in Lam's novel, The Invincible. So you're talking about all this swarm of smart dust. Basically, it's a collective intelligence. And human can learn so much from this kind of large model, because it helps us to perceive something beyond our sensory system and beyond human. Then we can be less human centric, and we can be more compassionate about other species, and maybe that would be the solution to fight against the climate change, because we can feel how the other species feel, and all this pain, all this suffering, all this sacrificing could be something tangible and real.
Wonderful. Imagining artificial intelligence in the model of humans is actually an inferior way of thinking about artificial. The more superior way, what you call the whole world model, is the way to develop.
Yeah, so this reminds me of Buddhism, because in Buddhism, like all the sentient species are as equal as possible, and there's not such thing as human beings supposed to be premier than others. So I'm always thinking about, we need to find a way to embed all this philosophy and values of Buddhism and Taoism into the machine, like into the model.
So I'm wondering, you understand the technical elements of AI. Can AI be trained in Buddhism, in Taoism? Because all the books and values are already codified. Is it possible to find AI that trains on them and creates a synthetic world religion, if you will?
It definitely could. And it could do a better job than any of the priests, any of the monk, any of the gurus in the world, because it's so knowledgeable. But as a practitioner of Taoism, there's something beyond the synthetic understanding of all this, call it religious or spiritual experience, is something embodied. So you have to do all this physical homework to practice, to hike, to meditate. So I think this is something still AI lack of. It didn't have a body. It didn't have the complex sensory system. It didn't have self-awareness, for example. And I think all of those part is what makes a human human. AI in the future, maybe it could be used to help us to reflect ourselves as a mirror, right? To make us become a better human being.
Thank you for listening to this podcast from the International Science Council's Center for Science Futures, done in partnership with the Arthur C. Clarke Center for Human Imagination at the University of California, San Diego. Visit future.council.science for the extended versions of these conversations, which will be released in January 2024. They delve deeper into science, its organization, and where it could take us in the future. Join us next week for this series' last episode, when I'll be speaking with Cory Doctorow on more themes related to the digital world.